Hey, welcome. This lesson is on add linear expressions. It's almost the same as simplifying expressions, but we can categorize it a little bit different into what a linear expression is. This lesson is found on page 395. So our essential question for this lesson today is, how can you use numbers and symbols to represent mathematical ideas? Again, with the variables, we're working our way towards equations. Okay, so right now we're just in expressions. A linear, we have our vocabulary word or words. A linear expression is an algebraic expression in which the variable is raised to the first power and a variable are not multiplied or divided. So some examples of linear expressions versus non-linear expressions is that if you notice that we have single variables here, some have coefficients, none of them they're to the first power. Over here we have a variable multiplied by another variable. That'll make it a nonlinear. You have x to the third, that's nonlinear, and you have x to the fourth. Basically, a linear expression, if it was in the form of an equation, would make a line. You could see the word line in the word linear. So what these do is sometime in the future you're going to use these expressions within equations and you're going to be able to draw a line from them. These over here will not make a line, they make some form of a curve or an ellipse or a parabola. But over here we have when we talk about linear expressions, it's a line. Okay, let's get into what does adding a linear expression look like. Let's take a look at number one, example number one. Basically, we have two groups here. We have 2x plus 3 plus, or the quantity 2x plus 3 plus the quantity x plus 4. The first thing you want to look at is this is all addition. So we see that this is all addition. So really I could just rewrite this. I could rewrite this as 2x plus 3 plus x plus 4. I can move these around. My commutative property allows me to move these around. I can move the parentheses around. My associative property allows me to do that. Why? Because it's all addition. So now what I could do is I could sit down and I can say, okay, well, let's just combine like terms. Well, what terms are alike? Well, you have 2x and you have x. You take those two together, 2x plus x, and we get 3x. Then we write down the rest of our problem. You could combine like terms again. Three plus 4. Okay, we get our 3 plus 4. We're going to get an answer of 3x plus 7. Okay, we can't combine like terms anymore. We don't have any like terms to combine. So we have an expression as an answer. Okay, the way you want to set up your answers when you have expressions is that you take all of your coefficients and you put those first. And really, when you put those first, depending upon how many variables you have, we only have one here, but sometimes you have more than one, we'll put those in A, B, C order. So anything before x would go first, and so forth. Then you put your constant. The constants will always go last. And that's kind of how we set up our answer. If you have them out of order, that's not a problem, but we're just going to try to keep them in order, and all of the answers that you see from me will be in that particular order. Okay, let's take a look at our next example before I have you guys try one. Now we see some subtraction or negatives. We can't just move parentheses around. We can't just move numbers around. What we have to do is I'm going to rewrite this problem so I can work with it. 2x minus 1 plus x minus 5. And what I'm going to do is I am going to add the opposite. And then let's change the color on that. Let's add the opposite. Let's add the opposite. Now I can move stuff around. I can combine like terms. I can see, okay, I have 2x and I have x. Same as I had before. So because I have x and I have 2x, now I'm going to have 3x. So I'm going to write that out. 2x plus x is 3x. Okay, but I also have my constant numbers are negative. I have a negative 1 plus a negative 5. Okay, that gives me a negative 6. Okay, so my answer is going to be, put your coefficients first, 3x minus 6, my terms. Now if you put plus a negative 6, that works too if you wanted to add the opposite, but this is in simplest form. And again, right here we are combining like terms. And then we show our answer in simplest form. And we did all this by adding the opposite. That way we can move these numbers around freely, or the terms around freely, without worry of messing up the problem. But you can't move those around until you're either adding or multiplying. That commutative property only works when you're adding or multiplying, not subtracting. So that's the first thing you have to do, is we want to add the opposite. Okay, let's have you guys try one. Go ahead and try this problem, see if you got it, and then come back when you are finished.